So today we're doing lesson 6.2 on car loans. So when you're buying a car, unless you can pay the entire amount up front, which most people can't, you would pay a down payment, so a smaller amount of money, and then you would borrow the rest from a bank or another lender. This is called getting a loan. Typically, the money is going to be paid back in equal monthly installments over a number of years, and you'll agree to that before you purchase the car. The amount of money that you owe the bank each month is equal to how much you owed the bank the previous month that's left on the loan times the interest rate that you all have agreed to and that you've signed for minus the payment that you've made. And so I have it written out in this recursive notation here that you're familiar with. So L sub 0 is going to be equal to the loan amount that you borrowed, and that's going to be a 0 because it's like the 0th month, right, when you borrow the money. And L sub n, the amount that you owe on the loan in the nth month, is equal to L sub n minus 1, the amount you owed the previous month, times 1 plus your interest rate, your annual interest rate divided by 12, since we're looking at monthly payments, minus that payment that you're making every month. So the most common number of months to pay back a loan is usually a 5-year or a 60-month loan, but there are definitely times when you can do a 3-year loan or a 6 or 7-year loan. It just depends on what you've agreed to. The longer the loan, the higher the interest rate you're usually going to get, and we're going to discuss a lot of that stuff later on in class. But I just want to talk about how you would set up a chart here in Excel to show the balance of your loan every month and how long it's going to take to pay a loan back, or what payment you're going to have to make, or how much of a loan you can take out. So let's look at question 1. It says if you want to borrow $20,000 and the annual interest rate is 6.5%, what is the monthly payment to the nearest penny if you are going to pay back the loan in 60 months? So think about the 3 things that are fixed here. So the first thing is your loan. So you're going to be taking out $20,000. Your interest rate is going to be fixed, and that's 6.5%, so 0.065. And your payment. Now, you don't know what the payment is right now. That is what we're trying to find out. We do know that it's going to be a 60-month loan. So let's set up a column for the month and a column for the balance on the loan. Remember to start at month 0, because at month 0, that's going to be when you take out the loan. So I want to generate a list from 0 to 60. So I'll use a basic formula. So this is going to be equal to A2 plus 1. That'll generate a 1. And now I can copy this formula down to a 60. And now let's talk about the balance. So the balance at the 0th month is just equal to the loan. You want to make sure that you set that, don't type 20,000 in here. You want to make it equal to this, because we're going to solve for this payment amount later. So now what I want to do is I want to set up how much I'm going to owe after I make that first payment. So I'll have this equal to the balance times 1 plus, got to have another set of parentheses for my rate, divided by 12, minus my payment. Ooh. So I don't know what the payment is here. Watch what happens, because I just have question marks here. It's going to give me this like hashtag value, exclamation point. It has no idea how to understand this formula because this F3 is a bunch of question marks. So what I need to do here is I need to set like a fake payment. Let's pretend it's $150. So you have to put in, if you want to make a note to yourself, you must put in something for the formula to work. We're going to use solver later in order to find this actual value. And here you can see if I make a payment of $150, then I'm going to owe $19,958. Notice if I take my loan that I borrowed minus what I borrow now, $41.67 only came off of my balance, but I paid $150. That means essentially $109 of that has just gone to the interest on the loan. So that's something to look out for. So I'm going to delete this because I don't really need it. Now I want to be able to click and drag, but watch what happens. Oh my goodness, what happened? You see how these numbers should be getting smaller. I'm making payments, and I should owe less money every month. The problem is when you have Excel and you're using this drag function, it recognizes your formula and everything starts to roll. So where I see B2, F2, and F3, they all roll. And now you want some of these to roll. You want my balance to roll because that's that previous amount. But the interest rate shouldn't roll. The interest rate is always going to be this 0.065 for 6.5%. And my payment is always going to be $150 for right now. So I don't want these things to roll. When it does this in this formula, it's reading F3 is my interest rate, this 150, and then this F4, well, that's a 0. So I'm making payments of 0 at this point. And then it rolls down. Now my interest is 0 and my payments are 0 because these continue to roll. So I'm going to undo that. And what I need to do is I need to fix my rate and I need to fix my payment. It's really easy how you do that. In Excel, if you put a $sign in between your column and your row, the letter and the number, it'll fix those for you. So you notice that number didn't change. All I did was I fixed these two items, and now I can click and drag. And there you see the numbers are getting smaller, which is good. And you can notice when you look at your formulas as I roll down, the B right here is rolling for the previous balance, but everything else is staying the same for my rate and my payment. So now I know my formula is good. Let's drag this down to 60, and I can see, whoa, $150 a month is not even going to be close to paying off this loan because I still owe $17,055.25 at the end of 60 months. So what we're going to do is we are going to use Solver now. I'm going to make this a little bigger so we can see it. We're going to use Solver now to figure out what on earth should this payment actually be. And I'll go ahead and I'll highlight this because I know this is what I'm looking for. I'm also going to split the screen. So if you go to View and hit Freeze Panes, what it does is it'll put this thicker bar. And this way I can kind of analyze what's going on down here without having to scroll down every single time. So what I want is I want this to be a 0 because I want the loan paid off. So I'm going to go to Data, Solver, and here I get my Solver function to come up, which you guys used in lesson 6.1. So you can notice that the objective is actually already set. It's right here, but just in case yours comes up and it doesn't have that cell, my objective is to make cell B62 a value of 0 by changing the payment. And now when I hit solve, it'll find what payment I should make. And there it is. So the payment that's going to get this done is a payment of $391.32. And if I make that payment for 60 months, I should be able to pay off this loan. So now we're going to skip down to question A. How much total interest do you pay on the loan? So I'm going to unfreeze the panes just because I need to do a little more cell work. So let's unfreeze the panes since I know what's going on down there. And let's look and see how much interest I pay on this loan. Well, to know how much interest I'm paying on the loan, first, I need to figure out how many total dollars have been paid. I'm going to get rid of this. So think about how many total dollars you've actually paid. It's going to be equal to the payment times 60 because you made that payment for 60 months. So notice you've paid a total of $23,479. Now the interest is equal to the total dollars you paid minus the amount you actually borrowed. So I'm setting up this formula here, and there you can see the total interest that you paid is $3,479 and about 38 cents in interest for this loan. So that's extra. So there's one scenario here. Number 1 is done. Let's take a look at number 2. I'm just going to go to the sheet here. It says if you can afford to pay $250 per month and the annual interest rate is 6.5% again, how much of a loan will you be able to get if you want to pay the loan back in 60 months? And then I have some extra notes here because this question is probably more realistic whenever you're going to purchase your first car and you're going to borrow money. Usually, You don't really know exactly how much of a payment it's going to be, but you know what you can afford. So you walk onto a lot knowing what kind of a loan you can take out based on what you can afford to spend each month after looking at your basic budget. So our setup is still the same. We've got the loan amount, which this time I don't know. You've got your rate, which they give you is 0.065. Nope, that'd be 65%, 0.065. There we go. And then the payment, which is fixed now, you know you can afford $250. And it's going to be a 60-month loan. So let's set this up. Let's set up 60 months. So I start with 0. And then let's generate a list from 0 to 60. There we go. And now let's set up my balance. I don't even know why I typed the equals on there, just a balance. So the balance is equal to the loan. But again, since I just typed in question marks, they're just going to set it equal to question marks. We have to put in some sort of fake loan. So let's guess. We knew that $391 got us $20,000, so it's got to be less than $20,000. Let's say, I don't know, $15,000. Might be a reasonable guess. Maybe I'll be able to get a car that's worth $15,000 if I can afford $250 a month. And now let's set up my formula. So in the first month, I am equal to the previous balance times my interest. So 1 plus my interest rate divided by 12. Don't forget the double parentheses, minus my payment. And think about whenever I start to drag this formula down, I want the rate and I want the payment to be fixed. So let's roll this down and let's see if $15,000 is going to be within my reach. Doesn't look like it. So it looks like I'd still owe $3,073. So I'm going to have to use Solver. I'm going to freeze the panes just to make life easier. Here we go. My advice is always, again, to click into your objective because usually that pops up for you. Hit Solver, and look, there the objective is here. So you want to set cell B62 to a value of 0 by changing, not the payment, the loan. I know my payment can be $250 this time. You're solving for the loan. Hit Solve. And there we go. Looks like I can afford $12,777.17. Notice here a lot of students and the last couple of classes have been saying that's not 0, but it is. This is scientific notation. So this is saying it's 0.0000000000 10 zeros and then 3919. So it's essentially just 0. And it's negative, but that doesn't matter. It's getting very, very close to 0. So now the next question, how much total interest will you pay for the loan? So I'm going to go back to view and I'm going to unfreeze these panes. And let's solve for how much interest is paid on this loan. So I have total dollars paid. I'm going to end up paying $250 times 60 since this is a 60-month loan. Well, that's $15,000. And now let's solve for the interest. The interest is the total dollars that you paid minus the amount that you borrowed. You pay an extra $2,222.83 for this loan. So that's the lesson on car loans and how to build a basic balance sheet for a loan.